Welcome children. Today class 9 mathematics chapter 7 triangles part 2 video. In the part 1 we have discussed triangle, what is a triangle, and two congruent rule, SAS congruence rule and ASA congruence rule, and exercise 7.1. Up to that we have finished it. And now coming to the next topic, isosceles triangle and its property, and then exercise 7.2. Okay. So now what is isosceles triangle? So in a triangle, how many sides? 3 sides. So out of 3 sides, if any 2 sides are equal, then we can say it an isosceles triangle. Iso means same, celes means size. Okay. In Greek and Latin language, it means like that. So we are calling it as isosceles triangle. You see, a triangle in which 2 sides are equal is called an isosceles triangle. So now the properties. There are 2 properties we can say about the sides and angles. This is the triangle ABC, and if 2 sides are equal, this is an isosceles triangle with the 2 sides AB and AC are equal. You see here, if AB equal to AC, then the angles B and C are equal. So angle B is opposite to the side AC and angle C is opposite to side AB. So that means angles opposite to equal sides. 2 sides are equal and angles opposite to that equal sides of an isosceles triangle are equal. And the next property, the sides opposite to equal angles of a triangle are equal. An isosceles or simply a triangle we can say. So the sides opposite to equal angles of a triangle are equal. So you see, PQR is a triangle. Here, if angle Q is equal to angle R, then the sides opposite to equal angle. So PR is the side opposite to angle Q. PQ is another side opposite to angle R. So sides opposite to equal angles are equal. So these are the 2 properties of the isosceles triangle. And now the first property we shall prove. You see here, to prove angles opposite to equal sides are equal in an isosceles triangle. Okay. So now let us consider triangle ABC with AB, AC, 2 sides are equal, and we have to write given in triangle ABC, side AB is equal to AC. To prove that angle B equal to angle C, because angle B is opposite to this side AC and angle C is opposite to this AB. So we have to prove angle B and angle C are equal. And now we have to draw the bisector of angle A. So that is the construction. To prove this property, we have to construct what? Draw the angle bisector of angle A to meet BC at D. You see, from this the text AD is constructed, which is the angle bisector. That means what? These 2 angles are equal. This angle A is bisected, means made into 2 equal halves. So this AD is the angle bisector of angle A, which meets this side BC at D. And now in triangle and triangle ADC. You see, ADD, you can take ADB, ADB, ADC, like that you can take. Both are same, but in order. ADB, ADC. Now we can see here two triangles, and first we have to prove these two triangles are congruent. I will say why we have to say these two triangles are congruent. Wait and see. So first, in these two triangles, we have side AB is equal to side AC. Okay, this is given. And then this angle BAD, or you can name it as 1, and you can name it this as 2 for our better understanding. So angle 1 is equal to angle 2, because AD bisect angle A. Okay, AD bisect angle A. This symbol is angle A. We have to write like that properly. So AD bisect angle A. So we have angle 1 is equal to angle 2. And another one pair, AD is common for both triangles. AD is equal to AD, because this is the common side. Okay, this is common side. You see, this is one side, one pair of sides. In these two triangles, this one pair of side AB equal to AC, angle 1 equal to angle 2, one pair of angles, and another pair of sides, AD equal to AD. So the both are same side, common. So side, angle, side. This implies SAS rule. We can say triangle ADB congruent to triangle ADC, because of SAS rule. We have already explained clearly in the first part. Okay, so by SAS rule we can say these two triangles are congruent. So after saying congruent, we can say by corresponding parts of congruent triangle, the other parts of the corresponding sides and corresponding angles are also equal. That you know, CBSE. So we have to say this angle, angle B equal to angle C. You can see easily angle. This implies angle ABD is equal to angle ACD. CPCT. In caps we have like corresponding parts of congruent triangle, which is nothing but ABD means angle B and ACD means angle C. That's what hence proved. Hence proved. What we have proved? In an isosceles triangle, if two sides are equal, then the sides, that is angles opposite to equal sides. Angles opposite to equal sides are equal. That we have proved. Clear? So like that, you try to prove the next property by using, I think ASA rule we have to apply there. You do by yourself, and I think this is in the worksheet. So you do by yourself. Think and do. Very easy. And now let us move to the exercise 7.2. So now, exercise 7.2, first sum. So in triangle ABC, AB equal to AC, they have given isosceles triangle, AB equal to AC, and BO is the bisector of angle B, and CO is the bisector of angle C. These two bisectors, BO, CO, meet at O. After that, we have to join this O with this A. Okay, and to prove OB equal to OC, see OB, OC. So you have to prove they are equal. And one more thing, AO bisect angle A. That means if we prove these two angles are equal, then we can say AO bisect angle A. Okay, so see, let us see how to prove that. The first one, the proof. First part, OB equal to OC, we have to try. Okay, so in triangle ABC, in triangle ABC, AB equal to AC. It is given. Then we can say by isosceles property, angles opposite to equal sides are equal. Since angles opposite to equal sides are equal, comma, we can say this is AB, the opposite angle C. So we can take it as ACB for our understanding. ACB, which is equal to, and AC opposite is ABC. Okay. So anyway, you can write ABC equal to ACB or ACB equal to ABC. Both are same. And now you see, these two angles are equal angles. Which two angles? This full angle and this full angle, okay, are equal. And now it is given that BO bisect angle D means this angle. For example, you can have 1, 2, and this is 3, and this is 4. Since BO bisect angle D means angle 1 equal to angle 2, that you know. And here also CO bisect angle C means angle 3 equal to angle 4. Okay. Now, we have proved by applying the property angle ACB is equal to angle ABC. So, this implies half of ACB is equal to half of, let it be equation 1. This will be used in the next part. Okay. So, equal angles when we divide by 2, that means multiplying by 1 by 2 or dividing by 2, both are same. Okay. So, half of both angles are equal also. So, to understand this, I will tell you this. 100 equal to 100 means, if you say half of 100, but they are also equal. Half of 100 means what? 50 equal to 50. So, like that we can understand. Okay. This is for your understanding, I am telling. So, half of the left angle is equal to half of the right angle. Okay. So, half of ACB means we can have angle 4. You see here, ACB is the full angle, and half of it means, you know, angle 3 is equal to angle 4. So, we can have angle 4. Okay. So, for that we have to write, since OCO bisect angle C, or we can write ACB. Okay. And BO bisect angle ABC, comma. So, because of this reason, we can say half of ACB is what? This is half of ACB is 4, angle 4. You can write as that is BCO or anything. Okay. You see, angle 4. For half of ACB, I am going to write OCB is equal to half of ABCB. So, this is 2. So, OBC. Clear? So, here these two angles are equal, 2 and 4. OCB means angle 4 and OBC means angle 2. They are equal, and since this angle 2, that is OCB means angle 4 and this is angle 2. For our understanding, we can write like this. So, these two angles are equal means in a triangle, then we can say sides opposite to equal angles are equal. Since in triangle OBC, sides opposite to equal angles are equal, comma, you can write what? OB equal to OC. OB equal to OC, because 2 and 4 are equal. So OB is opposite to angle 4 and OC is opposite to angle 2. So by this property we can say OB equal to OC. That is what the first proof. And coming to the second one, you see, AO bisects angle A. AO bisects angle A means you have to say these two angles are equal. BAO equal to CAO, like that you have to say. So for that, I am taking these two triangles. Okay, in triangle AOB and triangle AOC. So we have what, AB equal to AC, that's given. Next we can say this half of this angle ABC and half of ACB already we have proved, so we can take half of ACB is equal to half of ABC. From 1 we can write, because already we have given the equation 1 for that. So these two are equal, then we can say half of ACB means we can take now 1, because these two triangles only we are comparing. So now we can take 1. The angle 1 is half of, angle 3 is half of ACB, the side change, that's all. So for ACB, half of ACB you can take 3, angle 3, okay, the angle symbol is have to write. And for ABC means now we can take angle 1. Half of ABC we can take 1. Either 1 or 2 we can take. But now we are comparing these two triangles, so we have to take this angle 1 for half of ABC. So like that we have to take. So you see, angle 3 equal to angle 1. So these two angles are equal. And now, or you can write as angle 1 equal to angle 3 also. That's it. And now AO is common side. Okay, for both. AO equal to AO, that is common side. This implies, you see, one pair of side, here one pair of side. So two pair of sides and one angle. Okay, so here we can say angle 1 equal to angle 3 or angle 3 equal to angle 1, both are same. So SAS rule, we can say triangle AOB congruent to triangle AOC. This is side angle side rule, SAS rule. By SAS rule we can say these two triangles are congruent. So after proving congruent, the remaining corresponding parts are equal, that you know. Okay, so first these two we can have, that is the proof. The angle OAB is equal to angle OAC. This implies OA, the first triangle AOB, so we have OAB is equal to OAC. CPCT. The corresponding parts of congruent triangle, we can say these two angles are equal, these two. So they two equal means that is nothing but we can say AO bisect angle A. Hence AO bisects that's the proof. Okay. So now question number 2 you take as homework, because very easy only. The diagram is given, I will explain. A, B, C, and this is the perpendicular bisector. So in triangle ABC, AD is the perpendicular bisector of BC. So therefore, perpendicular bisector means it makes 90 degree with the base, and also it bisects the base BC. So why we are call it as perpendicular bisector? Is perpendicular and also bisects the base. So BD equal to BC. Okay. So now we have these two triangles. So we have to say show that triangle ABC is an isosceles triangle with AB equal to AC. So So for that we have to prove these two triangles are congruent, ADB and ADC. That we can easily do because 190 degree pair is there, one pair of sides BD equal to DC, and then AD is common side. So two pair of sides and one angle are equal, then we can say by SAS congruence rule they are congruent triangle. And after proving that congruent by CBSE we can say that AB equal to AC. Okay, this AB equal to AC. After saying that the two sides equal, then ABC is an isosceles triangle. Okay, so you take a homework. And now coming to the third question. You see, in question number 3, a triangle ABC is given and the altitudes BE and CF are given. You see here, ABC is a triangle and BE is the altitude drawn to the side AC and CF is another altitude drawn to the side AB. Altitude means nothing but the perpendicular distance from vertex to opposite side. So this is 90 degree, this is next 90 degree. Okay. And now the given part you have to take in the question. ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides. You underline this, equal sides. Which sides equal? AC and AB. So they have given. So AC, AB equal means I have taken like AB equal to AC. Okay. So this triangle AB equal to AC and BE perpendicular to AC and CF perpendicular to AB, so that we given. To prove BE equal to CF, where is BE? BE. The altitudes are equal. So like they have given. So you have to prove BE equal to CF and proof part. So for that you have to take how to prove it. You see, I will give some tips. Where is B and CF? You see, BE and CF, these are the two altitudes. So if you take this triangle AEB and AFC, okay, then we can prove it they are congruent. After that you see what happens. So in triangle AEB and triangle AFC, you see, what are the things we can collect? First of all, AB equal to AC, that is given. Isosceles triangle with sides AB and AC are equal. They can take this one. And then in this AEB, if this 90 means that also 90. So angle AEB is equal to angle AFC. In this triangle AFC, that we can take. So AFC both are 90 degree. And then angle A is common for both triangles. So angle A equal to angle A, that is common angle. Common means what? If it is common angle, then you can say common. So you can write the angle A equal to angle A. If it is side common, then write the side and write common. So you see the two pair of angles are equal and one pair of sides are equal. So these two angles is not included in the side AB and AC. Right? Can you understand? You see, AEB means this angle, okay, this angle, and angle A means this one, but the side is AB. So the side is not included in these two angles. So by AAS, two angles on one side. So AAS rule you can say. This implies triangle AEB congruent to triangle AFC. The rule is AAS rule. Okay. And after proving that these two triangles are congruent, what we have to prove? BE, CF equal. So BE is in this first triangle AEB and CF is in this triangle AFC. So you can say by CPCD BE equal to CF. So these two triangles are congruent means you see BE means BE, CF. That's all. By CPCT we can say these two sides are equal, that means altitudes are equal. That's all the proof. And coming to the question number 4, easily you can take a homework because it is given as like the third question, the diagram, the same triangle ABC and BE and CF are the altitudes to the opposite sides. And here altitudes are equal, they have given. The change is, in the first third term, these two sides AB and AC equal, and we have to say altitudes are equal. But in the fourth question, they have given altitudes are equal, and we have to show AB and AC are equal. That is, after saying AB equal to AC, these two sides, that is nothing but isosceles triangle. Which triangle? ABC. And triangle AB is congruent to ACF. The same thing. So this we have to say congruent. Through that, we can say easily that the two sides AB and AC are equal. And after that, the ABC triangle is an isosceles triangle. So like that, we have to say, take as homework. So now, coming to question number 5. So given that ABC is an isosceles triangle with AB equal to AC, ABC and another triangle DBC. In the diagram it is given. So ABC and DBC are both isosceles triangles with the base BC. So common base BC. Okay. And in the diagram it is given these two single marks. That means AB and AC are equal, and these two double marks, that means BD and DC are equal. So I have taken a given part. You see, it will be very clear. And to prove ABD equal to, you see, ABD is full angle and ACD is full angle or equal. Okay. So now, how to prove it? So if the two sides are equal, then angles opposite to equal sides are equal. That the property is there. Okay, you can apply that. Very easy to prove it. Listen. So in triangle ABC, AB equal to AC, since angles opposite to equal sides are equal, comma, we have A, B, C is equal to A, C, D. For your understanding, I am giving the number 1, 2. Okay? A, B, C means angle 1 and A, C, D means, sorry, ACB. ACB, that is angle 2. You can refer in the diagram. So ABC means angle 1 and ACB means angle 2. So they are the angles opposite to equal sides. Let it be 1. Equation number 1. Equation means we have to circle. And in triangle BDC, the next triangle, BD equal to DC, right? These two sides are equal, it is given. And the same reason, since angles opposite to equal sides are equal, so we can have, you see, this angle I am naming as 3 and this as 4. So that angle 3 means we can say DBC, which is equal to 4 means DCB. Let it be equation number 2. Can you understand? Just see angle 3, which is nothing but DBC, and angle 4 I am writing as DCB. So these two are equal. By applying this property, we can say. So from 1 and 2, we have to add. You see, if you add angle 1 and angle 3, what you get? You see the diagram and tell me. If you add angle 1 and angle 3, what you get? ABC angles. So this is what the proof here. Left side and right side, you see. If you add angle 2 and angle 4, what you get? Angle ACD. So that's all the proof. So we have to add. So equation 1 plus equation 2 Add 1 and 2 means equation 1 plus equation 2. We get A, B, C plus D, B, C is equal to the right side of the first equation is ACB and the second equation is DCB. This implies what is these two angles? That is 1 and 3. If you add, you get ABD. And if you add 2 and 4, JCB is angle 2 and DCB is angle 4. If you add 2 and 4, what do you get? ACD. From the diagram we can use. So hence the proof. Okay. Now moving to the question number 6. Now coming to question number 6. So it is given that triangle ABC is an isosceles triangle in which AB equal to AC. Side BA is produced to D. ABC is an isosceles triangle, AB equal to AC, and this BA is produced to D such that AD, AB are equal. So this AD, AB are equal. So anyhow these three sides are equal. Okay. So we have to prove BCD and this angle BCD is 90 degrees. BCD. So this angle is 90 degrees. This is right angle. Okay. You see how to prove it. So first, in triangle ABC, AD equal to AC. Okay. Given when BA is produced to D, we have AD equal to AB. Okay. It is also given. So from these two equations you see AB is equal to AC and the same AB is equal to AD. Therefore we have, this implies AC equal to AD. From these two equations we have AC equal to AD. AC equal to AD. So now we got two isosceles triangles. ABC, this one isosceles triangle where AB equal to A, and another isosceles triangle is ACB where AC and AD are equal. So in an isosceles triangle, after knowing the two sides equal, we can say by the property angles opposite to equal sides are equal, then we can say these two angles are equal. So name it as 1, this is 2. Okay, then only we can easily understand. And in this triangle, AC and AD are the two sides equal. So by applying the property, angles opposite to equal sides are equal, then we can say angle 3 and this is angle 4 are equal. Is it clear? So now you can take this angle, same triangle ABC, and you say since angles opposite to equal sides are equal, then we can say angle 1 is equal to angle 2. Angle 1 equal to angle 2. Let it be equation number 1. And in triangle ACD, which are the two sides equal? AC equal to AD. Okay. So it is an isosceles triangle. So we can say this implies angle 3 equal to angle 4. The same reason, angles opposite to equal sides. So they are equal, angle 3 and angle 4. So let it be equation number 2. Okay. And now our aim is to prove angle BCD is a right angle, that is 90 degree. So for that we have to consider the full triangle BCD, the big triangle. Okay. In triangle BCD, using angle sum property, angle sum property means what? Sum of the angles of the triangle. So in that triangle, by applying the angle sum property, so we can tell that angle 1 plus angle 4 is equal to 180 degree. Am I right? You see, angle 1 is here, that is angle B, and angle 2 plus angle 3 means BCD, the full angle. So this total angle is BCD, but we can tell that angle 2 plus angle 3. Clear or not? And this angle 4 is nothing but angle D. So all the three angles of triangle BCD, you have to focus only the big triangle BCD. How many angles? Three angles. What are they? One is B, another is D, and this is C. So this C angle is splitted as 2 and 3. So I am writing like this. This is one angle, this is another angle, and this is third angle. Okay. And now this implies angle 1 is equal to angle 2 from 1. So angle 2 we can replace for angle 1, and this is nothing but BCD, and we can have the same. I will tell you next step. Plus for angle 4 we can write angle 3 from the equation 2, which is nothing but 180, and reason from 1 and 2. So we can write like this. So you see here, angle 2 plus angle 3 plus again angle 2 plus angle 3, which is nothing but equal to 180 degree. So angle 2 plus angle 3 is nothing but BCD. Am I right? This implies BCD plus BCD equal to 180. So 2 angle BCD is equal to 180. X plus x, 2x. Such a way, angle BCD plus angle BCD is 2 angle BCD. So therefore, BCD angle is nothing but 180 degree by 2. What is that? 90 degree. Isn't it? If we bring this 2 here, what happens? 180 by 2. We get 90 degree. And we can say ECD, BCD is a right angle. Implies BCD angle is a right angle. Okay, children? And now let us move to the next sum. So now coming to question number 7. So the triangle ABC is a right angle triangle with angle A 90 degree. It is given in the question. So we have to make the angle A as 90 and other two sides are B and C here. Okay. And another thing, that these two sides AB, AC, these two sides are equal, that also given there. And to prove is, that is not to prove, to find. They are asking to find angle B and angle C. The measure of angle B and angle C you have to find. So they have given this only, and you have to find the angle B and angle C. Okay. So let us see how to find the angle B and C. So now, this is not proof. Okay, this is finding the angle. So in triangle ABC, 90 degree, so that is given. Okay, and then AB equal to AC, so everything is given. And then you know, in a triangle, if two sides are equal, then opposite angles of equal sides are equal. Since angles opposite to equal sides or equal, comma. So these two are equal sides. So for AB, this is the opposite angle, and for AC, this is the opposite angle, and we can say angle B equal to angle C. Okay, we can use here equation 1. That will be equation 1. Now, by angle sum property, in the same triangle ABC, we can say angle A plus angle B plus angle C equal to 180 degree. And angle A is given, that is 90 degree. So we can replace it. And for this, both B and C are equal. So we can use and replace, we can use that equation 1 and replace any one angle for the other. So for example, let it angle B, and for angle C, you put angle B from 1, because we are using equation 1 here. For C, I put angle B. So what happens? 2 angle B equal to 180 minus 90. Am I right? So bring this 90 degree to right side, it becomes 180 degree minus 90 degree. And in the left side, what happens? Angle B plus angle B, 2 angle B. And now, easily we can find angle B equal to, this is 90 degree. If you confuse me, better write. And now, next step, 90 degree by 2. So, angle B is equal to 45 degree. Okay. So, after finding angle B, you see here, both are equal, no? Angle B and angle C. So, therefore, angle B equal to angle C equal to 45. Both are equal angle, so each 45 degree. That's all. So now coming to question number 8. So it is given that show that the angles of an equilateral triangle is 60 degree. Okay, the triangle name is given, that is ABC. In the book it is given. So we have to draw the diagram. ABC is an equilateral triangle with all sides equal. Okay, we can take the sides are equal because it is equal to triangle. But the question is, we have to show that each angle is angle A, angle B and angle C are 60 degree. So this is to prove. So since it is an equilateral triangle, we can take the sides AB, BC, AC, all the three sides equal. And the proof part is, we have to say each angle is 60 degree. So see, let us how to do that. So proof part, the first, since AB equal to BC equal to AC in triangle ABC. Okay, come on. Take AB equal to BC. Since all the three sides equal, we take the first two parts, the first two sides. Okay, we can take like this. If you say these two equal, you see AB and BC, then these two angles are opposite angles to the equal side. Since we can say this implies for AB we can have C, and for BC you can have A. Within bracket you write the reason: angles opposite to equal sides. Okay, and let it be equation number 1. Is it clear? And take the next two, BC equal to AC. What happens? You see the diagram, BC and AC. So these two sides are equal means. So what is the angle opposite to BC? A. And what is the angle opposite to AC? B. Then the two are equal. So that isosceles triangle a property only. So you can say BC opposite angle is A and AC the opposite angle is B. The same reason, angle opposite to equal sides. You know that they are equal, so equal sign is here. So these are the two angles which are equal and opposite to equal sides, and let it be equation 2. Okay. So now you compare equation 1 and 2. Angle A equal to angle C, and the same angle A equal to angle B. So from 1 and 2, we have what? All the angles are equal. Am I right? A equal to C, the same A equal to B. Therefore, angle A equal to angle B equal to angle C. All angles equal. And now, we have to say each angle is 60 degrees. Up to this, we come to know all angles are equal. But the measure of each angle is 60. That we have to say now. So, in triangle ABC, by angle sum property, you can say angle A plus angle B plus angle C equal to 180 degree. Sum of all the three angles of a triangle is 180 degree. And keeping one angle as fixed, you replace the other. Okay. You see, this implies I am fixing the angle A as it is, and the other two I am replacing by A, because all are equal. So for B also I am writing angle A, and for angle C also I am writing angle A. So this is 180. You see what happens? You know, y plus y plus y, 3y. Yes or no? If you add y plus y is equal to 3y. The same way, angle A plus angle A plus angle A, 3 angle A. So, angle A is equal to 180 by 3, which is nothing but 60 degree. See here? Okay. So, now we got angle A is 60, and we can put here, and angle A equal to angle B equal to angle C equal to 60 degree. That's all. All are equal. So, if one is 60, then everything, all the angles will be 60 degree. And that's what the proof they are asking. Show that angles are equal to triangle cos 60, and we have shown it. Clear? That's all. The conclusion we can give. So, angles of an equitriangle is 60 degree each. Clear? So that's all the exercise 1.2, and worksheet will be sent to you. So please finish it then and there, and also the class work. Okay, thank you.